Hey folks, welcome back. In this video, we'll cover a live demo of Biologics Explorer software using the new top-down, middle-down protein sequencing workflow template. Okay, so the first thing that we'll look at is this workflow. And I'll go straight to the answer, right? So what you get out of it is, again, this UI that represents the answer, this bond coverage map, and its relationship to the underlying bond evidence that we get from the MS data. This is an EAD spectrum, and it's already been annotated by the software to label, which of these ions are A, B, C, or X, Y, Z ions, and through to, describing where in the protein, which peptides do these represent as fragmentation products from the larger protein. Okay, so maybe what I'll do is I'll kind of illustrate the relationship between these symbols, these bond coverage symbols, with the underlying kind of mass spec. So 𝗕𝗓𝗕𝗄𝑚𝑡. So this N terminus of the protein. There's this funny like triple F looking symbol, and it's telling us that there's A, B, and C type ions for this part of the protein. This DI peptide, we should find this in both A, B, and C kind of ion forms. And so if we look at the table bottom right, I'll go through this really slowly. Let me just scroll up. Okay, so the peptides are tabulated out, and I've sorted it so that we're kind of going in order, right, from the N terminus through to the middle. DI, DI, DI. You see that listed 3 times. If I select one, the A2 fragment in this case, I can have a quick look at the mass spectrum. The part of the mass spectrum that covers this part of the protein. And the software will automatically do this. It will go through and put a red color on the evidence, the mass spec evidence that covers this cluster, isotopic cluster, I should say. And so this is the isotopic pattern for the A2 ion for DI. And if I wanted to do the same for the next piece of evidence, the B2, I can just click on that, and the interface will automatically take you to that part of the spectrum. So the annotation, I'll kind of point at B2 ion for the DI peptide, and these are variable. You can change these in the settings with a right-click settings. And you can put all kinds of attributes here, whatever helps you and makes the job easier. I also have the ppm mass error listed on the very bottom. And then the same for C2. In this case, the C2 has, okay, so it's found 3 of the isotopes in its annotation. Okay, so that's kind of basically how the technology works, right? It's isotopic cluster recognition of the fragments in the mass spectrum, the MS-MS2 spectrum. And as you can see, it's automatically going and annotating and tabulating all the fragments and peptides that it's finding from the MS2 evidence. You can see the peptides grow in size. Here's an example of something a bit bigger, DIQ through to H, much longer peptide, C33 in this case, and if you mouse over it, the interface will kind of highlight using that red color all the pieces of evidence that describe this isotopic cluster. So you can see these peptides get really big in this protein sequencing approach. It's a good one. All right, so this one's, big, right? Really, really big. It's like a 4+ charge state, maybe more. Yeah, no, sorry, excuse me, 15 charge state. And it's you can see there's a lot of adjacent pieces of evidence, right? It's in amongst other ions. And what the interface is trying to do and the technology is trying to do is trying to piece apart and associate the right peaks with the right isotopic clusters. And so it's working very hard to do this for us. If I zoom in a little bit, just so that it's less distracting, you can see the red highlight again is trying to visually associate the isotopic cluster peaks for this peptide all together. And if you do want to try and confirm results, you can take the measurement tool and confirm charge state by taking a quick measurement, right? So the delta between those two is 0.06, and if you do that reciprocal, you'll probably get back to something like 15. All right, I'm going to continue to kind of scroll on down through the table. There will be an edge to this, right? So you get to the point where you get to the end of the N-terminal fragments, and then you'll start to see C-terminal fragments. And so this break happens around here. You see these DIQs kind of end, and then you see different letters. And so if you look over to the right-hand side, you'll see that the C-terminal side looks the same. Quite have my row wide enough, but you see these like C, E, G. That's that you're seeing on the far right side, and then these peptides will start to get smaller and smaller and smaller. Got my notes to make sure I cover what I wanted to cover. I'm just going to scroll on down. There was one I cherry picked here. All right, so this one is the example I wanted to cover. I wanted to look at this 29 C-terminal 29. So there's a few actual pieces of evidence here, right? There's a Z29 plus 1, another in a different charge state. There's a Y ion that it's found. Sometimes it can be a little confusing as to what you're looking at, which is why I find the labels useful, right? I've got it labeled Y29. Look for the red color. I always turn the labels on because I'm slightly colorblind. I can't always pick up all the colors. So the labels help me out. So if any of you are afflicted with the same thing that I am, make the labels work for you. Here's another complicated pattern. This cluster in amongst other clusters as well. Okay, so that's kind of a shot of what answers look like and the relationship that the answer is trying to drive between the protein sequence and the bond evidence through to the MS2 spectrum and the underlying fragments. All right, thanks, folks. If you want to learn more about Biologics Explorer software capabilities for middle down workflows and for full protein visualization, please contact your SCIEX sales representative.